Before we get started, does anyone want to get out?
So we have this rotations example from the 2018 exam paper. It says the figure shows an elevation of a gavel and a block used by a judge in a court. Also shown is the 3D graphic of the gavel and the block. Rotate the gavel ABC about point O until it reaches the surface LL1 of the block.
And I've just redrawn it out here so I can make it a little bit bigger for you to see at home. And I'll just go through the processes of these rotation questions, and they tend to be very, very similar in terms of process. So,
come with me if you want to live.
What we look at here is we have this, it's basically a gavel, which is like a judge's hammer. And this is the hammer and this is the base that gets hit to make the noise. Okay. Now, what we want to do is we want to rotate it into the position where it hits the line LL1. Okay? And we are rotating the gavel from point O. So, firstly what I'm going to do before I do any drawing is I'm going to label the points here. A, B, C, and D. Okay. What I'm going to do is I am going to put my compass on point O. So wherever point O is, that is the point you are going to rotate from. And when you think rotate, think compass. So, put it on O, measure to point A, like so. So what I'm going to do is I'm going to rotate point A down, like so. And I'll make my arcs nice and heavy so you can see them. And I'll add a little directional arrow here and there, so you can see that. Now, this is now the new position for A. We'll call that point A1. A1. Okay? So that's A to A1. Now what I want to do is I want to bring my compass back to point O, and I want to go to point B. Okay? And in fact, in the case of this question, B and O, they line up. They're on the one arc. Alright? So what we're going to do now is we're going to take the distance from A to B. Here. As it is on the gavel here. So I'll take that distance, measure it as accurately as you can. Bring your compass down to point A1 right here, which is now on the line LL1, and swing an arc. Now, where that arc intersects our original arc containing points A and B, that gives me the point B1. Why does it give me B1? Because from A1 to B1, that distance is not going to change. When we rotate it into a new position, it is simply transferring the distance somewhere along the arc. Okay? Now that we've established those 2 points, we can join them. Like so. And you want to always do these questions with the least amount of complications possible, because there's quite a few ways to rotate different points from here and there and so on. And look, we have one arc here now. What we found is the basis for drawing the rest of the gavel. So that's what we'll do. We'll draw the points C and D now, and then we'll get to drawing the line back to point O for the actual handle. Alright, now I'm going to take my compass again here, and I am going to swing points C and D into position. So compass on O, measure to C, it'll pass through D as well, as you can see, and swing that arc on. And you're probably going, well, where exactly now would these points be? Well, C is at a right angle to B, if you want to, it's directly above it.
Say hello to my little friend!
So what we do in this case is we get our protractor, is probably the easiest method when you're answering this into an exam. So, put the protractor on point B, center of it, line it up on the line connecting A1 to B1, and mark 90 degrees. Mark your 90 degrees like so, then connect B1 out to that point. Where that line intersects, we have our point C1. We repeat the very same procedure at point A1 down here. So line it up on the line, A1, B1, center of it at A1, go to 90 degrees, and then again another light construction line, and this point is going to be point D1. I then, with a degree of certainty now, I am able to connect those points like so, and like so here from D1 to C1. And now I have, add a little bit of colour to make it a little more visible to you. I now have the head of the gavel in its new position. Okay. Or the judge's mallet or hammer. Okay. Now we've only one point left, and we'll call this point X. Right here. So point X, it turns out, is halfway between A and B. The distance between A and B is 60 millimeters on my question here, as I made it out. So halfway between 60 there is 30. Of course you could swing the point around as well. For example, I could go to my point O here, measure my compass to X, and I could swing it through like so. Okay, the only issue I have with that method of swinging that around is sometimes the arc is very shallow to the line, and you could be a mil or two either side of the actual point without having being that inaccurate. So I think it's important to bear in mind that when you're swinging arcs to lines, they can hit very shallow. So in this case, all I did was I measured the line, I measured the distance, I got point X, I transferred it out. I knew it was, in the case of my drawing here, 30 millimeters, so I can call it X1 there, and then I can join X1 back to O. Okay? And if I want to check if that was all good and accurate, I can measure the angle there. Alright, it should be a right angle there, and it should be a right angle here, and it is. Okay? So that's a rotation with really only swinging one arc. I could have got away with swinging, I didn't need to swing the top one either, but I did. Okay, so I swung two arcs, and that was the rotation complete. So think about the other questions when you look through your exam papers, when you're looking at rotation questions, and think about the simplest way of rotating it. Okay, not being overcomplicated. So that's rotations, short questions. Have a look at them. Best of luck.
Hasta la vista, baby.